So good morning, friends, and welcome back to the online learning platform at Department of Civil Engineering. We are together for the course on Municipal Wastewater Engineering. And if you recollect, in the previous class, we had briefly touched upon sewer materials. Okay. And as a quick recap, when you go about selecting a sewer materials, there are certain criteria to be considered, such as what is its potential to resist abrasion, corrosion, what is its strength and durability, how heavy or light is the material, is it impervious enough to combat or prevent infiltration and exfiltration, overall what is its hydraulic efficiency, and finally when you speak about feasibility, is it economical, and is it of less cost that it can be afforded for any large scale or small scale projects. So in this context, we also had touched upon the issue of crown corrosion that you see on the screen right away. And we had discussed at least about 8 to 10 types of sewer materials, a few of which have been listed here. And as I told you, when we had discussed about these sewer materials, we had briefly understood what it is, okay, how do we go about using it, or that is what are its basic applications and what are its advantages and disadvantages. So as I am rushing through a recap with respect to different type of sewer materials, okay, you can make out that each of these sewer materials have a different appearance. Okay, when you look at the construction features, you can make out that some all of them do not possess the same features with respect to the diameter or with respect to the length. Also, you can see that so some of these materials are purely made up of cement and concrete. Okay, probably some of them also are composite materials, some of them may be also of plastics. Okay, sometimes they're also an upgradation with the sewer material. Okay, so each of these sewer materials that you had discussed, that we had understood in the last class, each of them came up with a specific application. For instance, with respect to its feasibility in handling, laying, transporting. For example, its feasibility with respect to ease in construction of small size or large size diameter pipes. For example, its feasibility with respect to having smaller lengths or longer lengths pipe, especially if you're looking at the stoneware sewers, especially because of the advantage it offers to be highly impervious to any aspect of infiltration or exfiltration. So every material that we have spoken about came with certain advantages and disadvantages. What we need to understand is, based on these advantages and disadvantages, where do they fit in best? Okay, where can they be applied best? Is it with respect to your main sewer line? Is it with respect to your laterals? Is it with respect to your outfalls? So moving on, after this quick recap with respect to the previous session, we should also understand that as we move ahead, okay, many of the sewer materials have more or less become outdated or obsolete, like the brick sewers that you see here. Okay, so since the evolution or since the civilization has started, the community has seen different kind of sewer materials. Okay, now probably this is the latest one, wherein you have a composite matrix, wherein we speak about glass fiber reinforced plastic pipes. We are not even talking about any additional security measures or safety measures with respect to your coating or plastering, whether it's your external surface or internal surface, because the pipe material itself is coming with all these in the first hand. Okay, while as you have noticed in certain other pipe materials, since they're susceptible to abrasion and corrosion, we had to go about doing additional treatments, giving it additional plastering on the external surface, or probably giving an additional coating on the internal surface with epoxy resin. Okay, so every pipe is different, the applications are different, and all of these are only based on the fact that what merits and demerits they pose. Okay, and finally again you have to decide it based on where it fits in best, where is that you're gonna use it. Okay, so friends, let's come to today's presentation. Today we shall be discussing about shapes of sewers. Okay, now in this presentation, first we'll try to understand what are the selection criteria when we decide which shape to prefer. Then we shall briefly understand the various types. Then I shall be summarizing it for you and listing the references. Now, when you basically speak about the selection criteria, there are actually 4 selection criteria. That is, when you want to decide what shape to choose. Okay, the first selection criteria is the stability aspect, that is the structural safety. Okay, the second one is with respect to maintenance, how easily can we clean the sewer. Okay, the third one is whether it is able to attain self cleansing velocity during dry weather flow. And the last one is it possible to provide sufficient freeboard, okay, during maximum discharge, that is your wet weather flow and beyond. So I'll repeat once again, when you speak about the selection criteria, you're basically talking about 4 parameters: structural safety, cleanliness, cleaning and maintenance, freeboard during maximum discharge, and then production of self-cleansing velocity during dry weather flow. So based on these criteria, okay, we go about deciding what shape of sewer to choose. Now, typically what happens is, when you basically say sewers, basically sewers are more or less generally circular pipes, okay, and these are actually laid below the ground level, wherein we tend to take the advantage of gravity, so we actually slope them continuously downwards towards the outfall. Okay, that is, we try to take advantage that the wastewater flows with gravity. Typically when I say shapes of sewers, there are 2 types: circular and non-circular. All right, so when you speak about non-circular, that is what we are going to understand further. We can have triangular, we can have rectangular, we can have parabolic, we can have U-shape, we can have X-shape. What you see is X-shape. Okay, further in X-shape we can have standard X-shape, modified X-shape. Okay, we can also have semi-elliptical, and probably also I will show you basket handle section. So typically when you speak about these non-circular sewers, okay, we are actually talking about the open and closed non-circular sewers. Please understand, friends, the moment you say open sewers, okay, we are only referring to those sewers which is carrying storm water, that is, which is carrying the precipitation, which is carrying the rainwater. And probably these open sewers are lined with materials, say, PCC or clay or brick or stone, that is to actually protect the drain surface from any kind of erosion or infiltration of water. Please remember one thing: while we tend to prefer open sewers for storm runoff, we always prefer closed sewers for sanitary sewage. Please understand, sanitary sewage is not supposed to flow in open sewers. Okay, it has to be transported only in closed sewers. So with this basic information, let us try to understand one by one the different shapes. Okay, now basically what are you looking at? You're looking at standard egg shaped sewer. Okay, now your standard egg shaped sewer, you can look at the shape, just try to observe, the pattern, just try to observe the shape of these sewers. Okay, they look like the shape of a egg. Now I may also call it ovoid, oval. Okay, now the standard egg shaped sewers, which are also called as ovoid shaped sewers, okay, whether it is your new egg-shaped sewers or your modified egg-shaped sewers, basically, they are meant for the purpose of combined sewerage system. That is, whenever you go for a combined sewerage system, then you tend to prefer these. Okay, now the idea is these sewers actually can generate self-cleansing velocity even if it is a DWF. That means during a summer season, during a dry weather flow, these kind of sewers will actually facilitate, they will actually help in creating self-cleansing velocity. They can actually avoid the silting. Okay, now what we need to understand is, these kind of sewers, they actually provide, I would not say on a greater scale, but let's say, slightly. So these kind of sewers, they slightly, they provide slightly higher velocity when you're talking about low flows. Okay, in fact, even your circular sewers cannot attain that. So the advantage is, when compared to your circular sewers, okay, if I have a egg-shaped sewer of the same capacity, okay, so if I'm comparing a circular sewer and an egg-shaped sewer, and let us say they're of the same capacity, these sewers are the ones which can generate higher velocity even if the flow is very less. That means, again, we are stressing upon dry weather flow. So please understand, in my repetitions, I'm trying to stress upon the fact that we need to understand that one selection criteria has been met, that is creation of self-cleansing velocity. Now let us look at the lob side. Okay, let us look at the lob side of your egg-shaped sewers, whether it is a standard egg-shaped sewers or your new egg-shaped sewers or your inverted egg-shaped sewers. Okay, the problem is, though it has an advantage, as I stressed before, there are certain demerits as well. Demerits, for instance, it is not easy to construct them. Okay, the cost of constructing them is higher. We need more materials, therefore the expense also increases. All right, and we have to also understand that this is not a stable structure, it is unstable, because you can see that the small end of the egg is down and it has to support the entire weight of the upper broader section. So let's look at this. Okay, have a look at this. So the smaller section of the egg is down and this has to support the weight of the broader section which is at the top. Probably this disadvantage has been overcome in the inverted egg-shaped sewers. Okay, now having said this, let me also tell you, when you go about using an egg-shaped sewer, we need to also make sure that there is adequate gradient. Okay, you need to make sure that these are sloping downwards towards your outfall. Otherwise, having said everything, it still cannot generate the self cleansing velocity. Now let's move further. What you are now looking at is again a non-circular sewer. So what do you see? Basically, you are looking at a rectangular shaped section. Now friends, in olden days, okay, in olden days when sewers were constructed, they were actually constructed of rectangular shape. Okay, so you can also see the materials of construction. You're basically looking at bricks and other kind of stone sewers. Okay, now basically what they did is, in olden days when they constructed these kind of sewers, okay, what they advented is, they used to have concrete which was laid at the bottom. Okay, and the sides, what you see is brick masonry. So at the bottom you have concrete lining. Okay, and here you have got brick masonry on either sides. But let's be very clear about this, friends. In today's generation, in today's era, in today's modern world, rectangular shaped sections are no more practiced. Okay, they have, even if they are, okay, what would happen is the masonry part of it has been totally been replaced with concrete. And even if I want to go for a rectangular shape section, okay, wherein I try to go with concrete all over, whether it is the bottom or the sides, okay, even then I will prefer it only for outfall sewers. Okay, now what we need to understand is, these kind of sections, they have got relatively high hydraulic mean depth. That is, at large flows, when there is huge flow coming in, when there is wet weather flow happening, they will have a relatively higher hydraulic mean depth. Okay, that means they can achieve higher velocities. If I again compare this section with a circular section, or let us say even an egg-shaped section, okay, of the same capacity, it is these kind of shapes which can achieve a higher velocity. Okay, when all the three are laid at the same slope. So this is one advantage of rectangular shaped sewers over others. Okay, wherein they are able to overcome the disadvantage of gradient. Okay, therefore these kind of sections are more suitable when we go for large size storm sewers. That is, when you probably talk about combined section, wherein you also have storm water gushing in. So what are the advantages? More stable, very easy in construction. Okay, fine. Now let us now move on to the next one. You're now typically looking at U-shaped section. Friends, basically these U-shaped section, These kind of sections are best suited for combined sewers, that is wherein you are able to handle or engage maximum flow of sewerage system, that is when you have maximum flow of storm runoff coming. Okay, these kind of sections are also best chosen when you go for long sewers. Okay, now when it comes to a modification, as you can see on the right hand side, you have the U-shaped section, but here there's a small modification. You have a U-shaped section with a connect. Okay, this is basically, my dear friends, it's a simple trench. Okay, it's just a trench. When you provide a trench at the bottom of the U-shaped section, all right, then it is called as connect. Okay, these are very easy to construct. Okay, now please understand, when you speak about these inverts, okay, when you speak about these inverts trenches, they may be flat, okay, or they may be smooth. As you can see, they can also be semicircular. All right, so the bottom of the invert can be semicircular or flat. All right, now typically the sides that you see, they are generally vertical. Okay, and the top may be flat or arced. That means, here you can see the top is flat, but here the top is arced. So this is a typical depiction of a U-shaped section. As I told you, we tend to go for this when you need to go for large sewers, when you need to go for long sewers. Okay, now what's next? Now basically you're looking at semicircular shaped section. So have a look at this. See, you have a section here. You can see the top part, you can see the arc. Okay, so the crest part is semicircular. It is not completely circular. Look at actual representation in this image on the left hand side. So friends, what happens is when you go for semicircular shapes, okay, these kind of sections, they give a wider base. Look at the base part of it. It is wider at the bottom. Okay, since it provides you a wider base at the bottom, it becomes highly suitable when you want to construct large sewers with less available headroom. So obviously the space available here is relatively lesser than the bottom part. So when you have a physical situation where there is a restriction of, there is less available space for headroom and you still need to go for large sewers, then this is the shape that you need to prefer. But friends, this kind of shape is also outdated, and yes, wherever it is being practiced, it's only meant for large sewers with heavy discharge. That is obviously your trunk sewers or your outfall sewers. Friends, actually these kind of shapes have now given way to rectangular sewers, which we discussed in the previous slides. Now let's come to the circular shapes. Now when it comes to circular shapes, okay, yes, as you can see, it is totally circular. Now we can easily manufacture this, and please understand, comparatively, this gives you a maximum area for a given perimeter. Now the best advantage of a circular shape sewer is it is very efficient, and the reason is it gives a very great hydraulic mean depth when the sewage is running half or when it is running full. Okay, so under both the circumstances, the hydraulic mean depth will be very high. Now apart from this, the advantage it helps is, we require lesser materials of construction. That is, it is economical because it is utilizing minimum quantity of materials. Now due to the curvature, due to the shape, okay, now there is also very less settlement of deposits. Okay, there are no nooks, there are no corners, they're all smooth edges. Okay, now what is that we can understand further, having an observation of this, it's pretty clear that, it's not just easy to construct, but very easy to transport, very easy to handle. That is, we can easily lay them. It's very stable, when it comes to laying. Okay, but the disadvantage that we need to understand with respect to circular shape sewer is, if you're talking about dry weather flow condition in a combined system, if there is a dry weather flow condition, then these kind of sewers cannot generate self-cleansing velocity. Okay, and also we need to understand these kind of systems are not capable of handling shock loads. Okay, so in case if your discharge is constant, then only it is best suited. In case If the variation of the discharge is very high, then these kind of sewers will not be able to handle them. Now, what you see on the right hand side is your semi-elliptical section. Friends, again, just like your circular shape or your rectangular shape, okay, if the idea is, if your objective is to handle large amount of sewage, then you have to go for semi-elliptical section. Okay, now let us say, you have a physical restriction, or let us say, not restriction, rather you have an option available given to you, wherein you can have sewers which has width greater than 2 meters. Okay, that means space is available for you, physical space is given to you where you can have a width more than 2 meters. In that context, we tend to go for these kind of sewers. Okay, please remember, look at the depiction, look at the top part and the bottom part. Okay, these kind of sewers, or this shape of sewer is more suitable for soft soil because they are very stable. Please understand, if the idea or objective is to carry low discharge, then this is not the shape that you need to prefer. All right. Okay, let's move further. Let us look at the left hand images, that is the parabolic shape, before I go for the last one, which is the basket handle shape. So when you talk about your parabolic shape, okay, yes, look at the depiction, look at the shape. Okay, just observe the physical image here and look at the schematics on the left hand side. Okay, your upper arc of the sewer is in the form of a shape of a parabola. That is why it's called as parabolic shape. Just observe once again as I move the cursor. See this top part, the crest part, the upper part, okay, the upper part here, it is actually in the shape of a parabola. That is why these are called as parabolic shape sewers. All right. Now, unlike any other sewers, the advantage of these kind of shaped sewer system is, if the target or objective is to carry small quantity of sewage, if that is the idea, then these kind of systems are best. Okay, now when you talk about the invert part, see this is the invert part, right, the bottom part. When you talk about the invert part, now this invert part can also be parabolic or it can be elliptical. All right. Okay, now let's go to the next one, which is your basket handle shape. Now have a clear depiction, or just look at this image once again. Just look at the shape of it. Okay, now see here the bottom portion. Look at the bottom portion. Compare this with the top portion. The bottom portion is actually narrower. Okay, if you look at the width, look at the width. Compare the width of this and this. The bottom portion's width is narrower when compared to the width of the upper portion. Okay, now friends, what happens is, during let us say a dry weather flow or a lean period, okay, that is when the discharge is very small, what happens is, it is your bottom portion which carries the small discharge. And let us say during your wet weather flow or during monsoon season, then when the sewer is running full, then it is the top portion, what you see here, which carries it. So what happens is, this kind of shape is very useful when you want to maintain a self-cleansing velocity during dry weather flows. But friends, again, this shape is outdated. Okay, please understand, it's not very easy when it comes to handling it, laying it, cleaning it. The maintenance part actually is a troublesome issue. Okay, now the very simple reason why we call this as a basket handle shape is because it resembles the shape of a basket handle. Okay, let's come to the last one, horseshoe shape. Okay, now yes, obviously, it is because of the shape of a horseshoe that you name it like that. Now, and the friends, these kind of sewer systems, these kind of shapes are best suited when you're talking about large discharges. That is, you're talking about the trunk sewers, or you're talking about the outfall sewers. Okay, now the suitability aspect of this is, when the space given, or there is physical restriction with respect to headroom. Okay, so when there is such a restriction that the headroom for the construction of sewer is limited, then we can go for these kind, because you can see that the headroom is relatively lesser when compared to the rest of the portion. Now the invert of this section, that is, I am talking about this part, okay, the invert of this section, or as you can see here, invert of the section, now it can be flat also, sometimes they go for circular, or sometimes they go for parabolic. Now when you look at the crown, that is the crest part, when you look at the crown, okay, now this is, you can see now it is typically semicircular. Okay, it is typically semicircular, and the idea is, it can support extra external loads without the aid of any backfilling. Okay, now when you talk about if, let us say, I want to go for sewers and tunnels, okay, then this is the type that I would rather prefer for. Okay, so friends, what is that we have understood today? We have a brief understanding of what are the various shapes of your sewer systems, and how do you go about selecting them. Okay, and we also have a brief understanding of what are the relative advantages, disadvantages that each kind of shape offers. For instance, probably with respect to handling the discharge, small discharge, large discharge, okay, probably with respect to convenience in installing it, constructing it, laying it, and maintaining it, that is cleaning it. Okay, and yes, most importantly, okay, is it able to generate self cleansing velocity. So friends, we are done with today's presentation, a small presentation on the shapes of sewers. In the subsequent class, okay, we shall be understanding about laying and testing of sewers. All right. So I thank you for your kind patience and kind attention. And now the session is open for any questions and answers that you have. Thank you.